Hi, Joes. And Joes, is it pronounced correctly or half correctly?
You can pronounce it Jose if you want.
Jose.
That's closer to the French pronunciation, but every country has its own way to pronounce my first name. It's a mess, so yeah, that's fine.
Jose. Jose is
Jose is
French.
fine. Yeah, Jose is in French. Yes.
Okay, how are you doing, Jose?
I'm fine. Nice Monday morning, rainy.
Rainy.
Typical November.
Okay.
Which is just fine.
Let's see how your memory actually is. How well trained your memory is. What was your first computer?
My first computer,
Yeah.
which is not the first device I wrote some code on, because the first device I wrote some code on was not a computer. And my first computer, the real first computer I owned, was in 1983, and it was called an Oric 1.
Oric
It was
1.
kind of small computer that you could plug on a TV set, and you had like 64 kilobytes of memory on such devices, and you could program it either in directly in assembly, or there was a basic language, you say programming language integrated on it, so you could write programs in BASIC also.
Is it like a French computer? What is Oric? I never heard.
I'm not sure it was French, actually. I think it was sold in other countries also. Maybe not in the US, but in Europe, at least in England. I think it was maybe an English machine. These were the day of the Sinclair ZX80 and ZX81. So this was the same kind of machine, you see. And I think English people were very good at doing that.
So is it Oric? O-R-E?
O-R-I-C. And there were several models of them.
Okay.
And the one I own was the first one.
So what's even more interesting, you wrote some code, not on computers, or what was it? This is I'm more curious to know.
There was electronic calculators, and you could write code on them. Texas Instruments was selling some of them. And I was the real first device I wrote some code on was a TI-57. That was a great calculator. And it was in 1979, maybe 1980, something like that. It was a few years before I owned this computer.
And why you did it? So why you started to write code on a calculator? So I mean,
that was exactly only for the fun of it, because there was nothing you could. I mean, at school we didn't have any courses on that. We didn't use them to do anything more than typical physics calculation, where you have trigonometry and all this kind of thing to compute. So you have this calculator that just helps you, but there was nothing to you couldn't draw anything on the screen. That was you remember these red screens with you have numbers were only displayed with several segments.
Yeah,
you had all the segments you needed to write 8 with squared 8.
My grandfather had a watch,
maybe,
which was almost like an Apple Watch. It was black, but if you push a button, you see the segments in red. It was incredible.
Exactly.
Yeah. And I also had such a calculator. It was actually beautiful, but I couldn't program on it. I remember it was a very basic one, but there were segments, and with big buttons. So the physical design was incredible, but it was a dumb one. There was no. So I'm asking because back then there were games, but I forgot they were like hardwired games to the hardware. So it was like it was horizontal thing with 2 buttons, and you can only play one game. It was not a computer, also with LCD display. And I also assumed you can extend it somehow, or if you play long enough, something will happen, and nothing happened, of course. So if I had such a calculator, I would also try to do something with it, just to see what you can do with it, because all such electronic things for me were magical devices, right? So I always wanted to do something with it, but I had no idea what to do. This was my problem.
Yeah, there was this kind of machine. Actually, you could program them using some kind of very basic assembly language, and you had. They used to be called steps in your programs, which was basically an instruction, and you had 50 steps to write your program. So like 50 bytes of memory.
And what you did? You remember the program you wrote on the TI?
I like I remember I did a program to compute the decimals of pi, because there was no memory. Well, there was memory on it, but not memory that could live. If you switched on the calculator, everything was erased from
Mm-hmm.
it, which was not the case for other calculators that came after.
Mm-hmm.
When you switched on, actually switching off the calculator was only switching on the display, and all the programs and the memory that you had in a calculator was still there. It was not the case for the TI-57. So there was no pi in it. See, if you wanted to compute, I don't know, the surface of a circle, you had to type 3.14 by hand. There was no constant on the calculator. And I just wrote a little program to compute pi, and I had it running overnight to have a precise value of pi. There is this funny formula that if you compute the sum of 1 divided by the square of n for all the values of n, then the value is the square of pi divided by 6. So you can actually compute
how you knew that? You were a kid back then, right? I assume.
I was in high school. Well, I
Okay.
knew it was. I knew it.
Okay, so so you were interested in math.
This is well, kind of basic math.
Yeah, basic math. What I have to tell, I have the problems actually to to find the connection between programming and math. Now I see everything is math, but back then for me math was boring and programming was exciting, right? So it was a long time, so I couldn't find the connection. But it is actually math and programming are very, very similar, right?
Yeah, there are many things that are taken from math in programming, especially with the more and more complex languages that people are using. People are talking about algebraic data types and this kind of thing. So algebra comes from is a theory that is coming from math, obviously, even if it's not really an algebra, because actually when you compute things on computers precisely, all the properties that operators have in math are lost when you're doing that because of approximations. When you're using pi, it's not pi that you have. This is just an approximation of pi, and that's it. And that's the case for every kind of number you're using. So actually, computing with even with double precision numbers, it's just like computing with integers, but with a mapping between both. And so you're losing basically all the properties that you have in math. I mean, you probably try to write this small program where you just took 0.1 and you put it in a loop and you sum it 0.1 plus 0.1 like 10 times, and you don't get 1. In the end, you have an approximation of 1.
Yeah, in JavaScript it's even earlier, right? So in JavaScript was the problem if you do it just 1 plus, it didn't work already, I think.
It doesn't come from Java. It just come from the fact that you use it doubled or floating point numbers. 0.1 is just an approximation of 0.1. So if you sum everything up, the error you're making on this operation actually increases up to a point where you don't have 1 anymore.
This is why we have big decimal, right?
Yeah, kind of.
Very good. So what you did with the real computer? So we do calculator. Were already skilled Pi developer.
I just like to tinker with the programming and see what you can do with any kind of thing. Like it was pretty limited on the. I mean, I was still in high school, so everything about programming is very light at this time. Plus, it was not like you could create some kind of fancy web page with like 2 lines of JavaScript. It was really not like that. Having a graphical screen was about being able to draw a point on I don't know, you had like 300 pixels in the width of the screen and maybe 150 in the height. That was it. This was high resolution.
You're right. I forgot actually the resolution of ZX Spectrum I had. 640 while 480 was way later, and this was already high resolution. I think this was the first PC, and before that it has to be far less than this. 320 maybe by something, right? I guess.
Yeah. This was, and it was super slow. I mean, drawing a circle on such a screen, you could see literally the circle drawing itself. Like,
you're right.
And after about 1 second, the circle was drawn.
Even with the logo programming language, it was slow because it was slow. because right now you wouldn't even see, the turtle moving, but back then you actually saw that it moves on the screen without any slipping, right? I think it was the logo programming language. I don't think it was artificially slowed down. It worked as fast as it could, right?
I can't remember, but you're probably right, because
Yeah.
these were the computer I'm talking to you about. It was about the time there was no logo support on it, but computers supporting logo were just like this one. It was the same period of time, and it was super slow. I mean, drawing this little turtle that could turn and then advance and then turn again and advance, it would take ages to display that.
Yeah, exactly. And there were programs where they draw, like a star, so you could see actually how it draws. It was fast, but it's still you could see moving, the turtle on the screen. So I never thought about this. I thought, the first time I recognized that the computer was that slow, as I had in memory, I thought, that there was like a demo mode, so they could show, how it works, a debug mode, but the debug mode was real. So okay. So what happened then with your computer? So you just use your computer to follow your math curiosity, or what happened with the computer? So which programs you wrote? What you are interested? What interests me? Why you did it? So because to be better in math, or what you wrote and why?
It was really for the fun of it. I mean, created like automatons and this kind of thing. You could write funny algorithms, like, for instance, create a maze randomly and try to make it random up to a point where the maze actually has a solution. That is, you can go from point A to point B, and there's always a path between both.
So backtracking.
Once you and it was backtracking. Come on. when you have like 40 kilobytes of memory to write your program, I don't think so. And then and then once you have that, try to solve the problem and find your path actually that you created. This is the kind of thing I was writing. I was pretty much in math at the time. And there were many things in math that were just funny and funny to try on this kind of machine. Just nowadays, computing is. I mean, every time you're trying to do something in math, there's a computer involved. There's some computation and a computer involved. Everybody's working like that. But at the time, it was not the case. This was This was the time where people had supercomputers. Maybe you remember these computers like Craze or thinking machine computers or Sun SPARC, those massively parallel computers, which were pretty powerful, by the way. And people were just trying to write code on this to solve, not necessarily to solve algorithms, but to solve problems with algorithms that required a fair amount of computing power to be solved, and to if you take the problem of the traveling salesman, for instance, which is there's no algorithm to solve this problem in an optimal way, only random algorithms. But if you want to solve it using a random algorithm, you need to have a fair amount of computing power to do that. Of course, now on a PC, you just program it, hit the button, and after 2 seconds you have your result, and it's a very good result. But back in the days, when you had like 0.1% of the computing power that you have nowadays.
Yeah. By the way, I was very fascinated by the Cray, and also the fact that the Cray had a seat, where you can sit down. And it was a beautiful machine. And there was even a story. I don't know whether it is actually true, that they had lava lamps, the Crays, for random numbers. So later. So. And what also a story, also don't know whether it is true, that the Sun E10K, it was like a powerful machine from some microsystem, had the backplane of a Cray, because I think Sun had something to do with Cray back then. So this is why I was fascinated by the Sunfires, E10K, and Crays.
So I think that Sun acquired Cray at some point.
Ah, okay.
Took the technologies and integrated part of the technology in their own, because Sun was creating microchips. Back in the days, Spark T, something,
exactly.
Spark T3, and this kind of thing. And I think that they were part of the Cray technology embedded in this Spark T3.
Yeah,
This is
somehow
something I
the
read
story was
somewhere,
like the the connection, the high speed connection between the backplane was from Cray. This is what I had one. This was interesting story. So I was always fascinated by. Was ETNK a supercomputer? It was, right? Kind of. It was like a server. So we use it as a server for application servers, but you could call it supercomputer actually. And it looked beautiful. You saw an ETNK? You saw an ETNK?
Yeah. I saw the Cray. I saw. I think it was a YMP, a Cray YMP. So I don't know if it's the same model as the one you're talking about. But the core CPUs were stored in some kind of glass cylinder with, so you could actually see them, and it was in a liquid nitrogen, so minus 200 degrees, just to keep them cool, very cold. And when you were launching computing on the CPUs, because the CPU were heating so much, you could see small bubbles of nitrogen. So you knew that the CPU were working because you could see these bubbles.
That's pretty cool.
Floating on the liquid.
I never saw a Cray. I only saw the ETNK several times, and what the chassis was is beautiful. It was like, it looked like it's a really nice machine from outside. So I always enjoyed to look at it. Yeah. So interesting. So what happens after your first computer? So what was your next step? So what was your next computer?
The next step was no computer for like at least 3 to 4 years.
Okay.
Because I was working and there was no computer and I didn't have the time anymore. After high school, and then when I was back in engineering school and math, then there were computers again. Yeah.
Which
we mostly had the Sun machines.
Oh,
Sun
okay.
SPARC 10, which was a beautiful machine. Oh my god, I so much love this machine. And then all the evolutions of the Sun SPARC 10, there were many. Also CMD machines like. There was this machine in near Paris, built by Connection Machine. That was the name of the company, and they made a specific that was a massively parallel computer called the CM5, and it was just an amazing machine.
CM5.
Even visually, it was a set of like big cupboards, black with a red. LEDs lights that were flashing when the CPUs were working, so you could see just like in Star Trek and these kind of movies. It was real, and there were real computations made on this machine.
The industrial design for the machines back then was incredible. So ETNK was perfect. I never saw the Cray, but I assume it was also great. But so ETNK, I can say perfect. Then there were the various workstations from Sun. So the tower, maybe it was the 10 tower. Because from time to time, I delivered courses at Sun Microsystems, and I had the tower workstations, the SPARC towers. And then what I wanted to have one, but this was the Silicon Graphics, the Octane machines, also beautiful design. And I never heard about the CM5, but I think it's the similar territory. And the one from Steve Jobs, how it's called before he went to Sun, there was like, they were like also the
Next Cube?
Next Cube, exactly.
Next Cube, yeah.
Also, I saw one, and from outside, really nice.
Yeah, and because it was Steve Jobs, he also worked very hard on the look and feel of the window manager and what was called the Finder or something.
So what you did with all the great machines back then? So what you programmed?
I was mostly I was working in a math research lab.
Wow!
I was a PhD student, and we were mostly kind of testing the algorithms we were working on.
Which algorithms? So just interested. What you did with the algorithms?
We were working on image processing algorithms. So different. There are different fields actually in image processing. There are people who try to enhance the quality of images, like deblurring them or this kind of thing. And but we were more in the pattern matching, but in image processing sense and the computer vision part.
Now it's your big time. Now it's your big time because the stable diffusion what it does, right? So this is the entire trick that they blur and deblur the images actually and this is actually now your time. Yeah, you could become the stable diffusion expert and hopefully put Java somewhere there, right? So.
Yeah, maybe. Why not?
Are
But
you interested now with
this was
the
mostly
image generation by AI, or is boring for you?
it was not we were not working on image generation, but mostly on image recognition.
No, but back then, you become expert
Uh,
of images, and now there's the image generation by Stable Diffusion and DALI and stuff like that.
mm,
And with your knowledge, you can appreciate more what happens right now. So, right. So what's the question? What's your? Mhm.
I guess so. To be honest, I didn't watch much what DALI and Stable Diffusion is doing. I tried to generate a few images with
Mhm.
it, and I came across so many glitches,
Yeah. This is,
horrible stuff.
but
It
it's
gives me a
amazing that it
picture of a
works at
dog,
all,
and the
right?
dog has a head of a horse.
Hmm.
If he has only one head, then you're lucky.
Hmm.
He has like three tails.
Hmm.
Come on.
You should try with Java Duke. This is always nice. What you get back. This is
Oh,
not Duke at
okay.
all. It is like crazy stuff. Hmm.
I'll give it a try.
Hmm.
I'll give it a try. What I think, even with ChatGPT, I think that the big thing with ChatGPT is that it's able to generate impressive sentences, even if the content is rubbish.
Hmm.
It says it in such a beautiful way. It writes it in such a beautiful way that you're tempted to say, "Oh, this must be very nice. This must be so accurate." And then when you dig deeper, you see that, oh my god! Even the code that it generates. Every time I watch a talk and a conference and see, oh, look at this. This code has been generated by ChatGPT. Yes, okay. So there are at least 3 bugs in these 50 lines of code,
Yeah.
or 15 lines of code. How
Yeah.
do you plan to fix them if you don't know the language?
Exactly. This is actually, I was on an internal conference and I was asking now about my opinion about the AI and ML and machine learning, and how I see this. I don't know whether you remember, there was like 2003, 2006, a big movement to offshore. And
Mhm.
the dream of European managers was to write a spec, and hand over to an external team, and they will code it for you, right? So
Yeah.
how I see the entire thing. Imagine ChatGPT could read your mind, right? So for 2 minutes, and
Mhm.
I say I would like to have such a program, and it will generate the code for you. So if it comes back, it is mission impossible that the program will do whatever you expected, because then you see, okay, now it is what I thought, but now I have it. So I would like to have something different. Where I'm going with it is you will get so much code, and without reviewing the code, it becomes unmaintainable in a second. So the only chance you will have that you will write, so the specification has to be longer and longer, because at the end of the day, ChatGPT is a code generator for me, right? So it there is a short specification and it generates a lots of code. Now the question is, how much information can you put in the short specification that it is correct? You know what I mean? And
Mhm.
this is the problem with code generators, that actually if you generate a lots of code from information, you have to understand the code or just completely generate the code. But if you have half generating and half understanding, it is a nightmare. But I think where ChatGPT is useful, if you already know the language well and it generates some code, you get maybe different ideas. So sometimes I use ChatGPT and
Yeah.
I say, this was an interesting idea, what I see here. Let's keep it this way. But I throw away 50% of the stuff. I don't like it. But sometimes there is a good idea. So it's actually a funny thing, just to learn more if you know something already. But it's a disaster. I wouldn't use, for instance, ChatGPT to generate Python code, because I have no idea about Python. I would, if something happens, I cannot help, except submit to ChatGPT and ask again, what is the problem? Because if it generates complex code, I have no idea what happens, right?
Mhm. The problem is the problem of confidence. Are you confident in the code generated? And every time I ask this question to someone who is presenting something about
Mhm.
ChatGPT and telling me how it's great at generating code and stuff, I say, okay, oh yes, I'm very confident in the code generator. Then why do you generate code? Why don't you generate directly the jar or the
Exactly,
executable
exactly,
file or the
exactly,
program?
exactly.
If you have 100% confidence in the code generated, then why do you generate code in the first place? Just generate the executable and run it, and that's it.
Or assembly.
So
Why jar, right? Why jar and not
or
machine code?
assembly,
Yeah.
exactly. Exactly. So I'm pretty sure that even the people that are super in this kind of thing and think that will explain you that it's great, that you won't need any developer in the world in like 5 years from now, which is just a joke for me, of course. Um, they're actually not being very honest with themselves, because if they were, they wouldn't be showing code. They were just showing executables and applications directly. Hey, make me an application that does that. Here, the executable, I'm going to run it and I'll see.
Yeah, exactly.
Yes, and I'll be 100% confident. And this doesn't happen. So it means that people are not confident in what they're generating.
No, it's good to get some conference talks. But what interests me,
Yeah.
all the AI talks at Devox, they were actually not that popular, as I suppose. I think, everything which is ChatGPT, whatever, would be the skyrocket. But Java developers are somehow more critical, I guess, because it was not like, this would like everyone would like to see the AI. It's more maybe old news already, right? In our okay, perfect. So you try to have an image recognition algorithms, right? So you try to find things so it's more like classification problem what you did, right? Or
it's classification, recognition, registration, this kind of thing.
Cool.
And every problem is actually specific. If what you're trying to do is recognize like faces of people in security cameras in airports, it's not the same kind of problem as when you're trying to analyze aerial images with buildings and you want to count or validate the buildings that your satellite images are showing you. It's not the same kind of problem. It's not the same kind. Maybe you will have similar algorithms, but they will just be adapted to the problem you want to solve precisely, just to because the problems are different. I even worked on it's funny because I even worked on the astronomical images to images of the sky, and people want to recognize a star, make sure that that star on this image is at this place on that image.
Okay.
And so it's a matter of matching images like that. So I also worked on this kind of algorithm. And it was funny because we had a discussion in a conference back last summer. A guy showed up and talked about this exact problem. And
at Devox, right? There was a guy with JavaFX with.
It was not at Devox. It was at jCrete.
Okay, but at Devox there was a talk about star recognitions with JavaFX.
Okay.
Very interesting talk, actually. And which programming language you used?
Back in the days was mostly C code, some pieces of assembly code, and these super parallel computers were programmed with their own language, which was a version of C that was adapted to the parallel computing. So it was mostly very low level language.
And you also did it?
Yeah.
It's like incredible.
Yes, I did it.
So you are like like a rock star back then, right? Not how to call it. Yeah, of course. Right now, even more. But I didn't knew that this is your background. It's actually interesting stuff you did. And you worked for Sun back then with all these Sun?
No, I didn't. I worked in I worked in a research lab here in Paris. That still exists, by the way. And we had access to this wonderful machine. We actually owned one, which was called the MASPAR. And we had access to this CM5. We didn't own it, but we had access to it, and we were able to launch to write code on it and use its computer.
And you developed on Sun and compiled and was submitted to the machines. Yeah, with Emacs VI. Yes, what was your IDE back then, or?
You want to drag me to this old Vim versus Emacs debate? So I was using Emacs. Don't ask me why, because it was like that. And I was super productive and proficient with it, so I was happy with it. And then I came across some people but Vim is so much better. And I just looked at them working with Vim, and they were super productive and super efficient and super fast with it. But it was kind of the same. Moving from one to the other was, okay.
What I remember, as I got the first time Linux, this was at the beginning of Linux, I tried to learn Emacs and I couldn't. But it wasn't even a programmer, right? So I started with everything. And with VI, I was able at least to save and overwrite. It was somehow easier for beginners. This is my why I stick a little bit with VI, but I was never good in VI. I was able, to edit some basics and save it. This basically was. And then I used Kedit in all the others, visual editors, but never text. And
there
just
was
curious.
No visual editor at that time. Everything was made
Not
We were
Sun
using
Workshop,
CVS.
Sun Studio Workshop for C. They had specific, IDEs. Which what I remember, what Sun did, they had also optimizers for the C. They were C compilers. There was a big deal back then. And I thought you
Yeah.
used, the Sun Studio Workshop for C. Another question: was the syntax highlighting for Emacs, or was it customizable, or was black and
Yeah.
white? Yeah.
If you were lucky enough to work on a colored screen, not all screen were colored
Yeah.
screen,
Yeah.
but if you were lucky enough to have that, you could have the syntactic coloring for any language. By the way, there was support for all the languages of that time: C, Pascal,
Mm-hmm.
Lisp, um, Fortran.
Mm-hmm.
Uh,
Cool.
Even assembly language, you could have syntactic coloring for it.
Mm-hmm.
LaTeX, I use LaTeX a lot.
Mm-hmm.
Any piece of documentation you were writing back in these days was written using LaTeX.
Mm-hmm. Just like
PC was not a thing. It was before Windows 95, which was, and everything on PC was complex. I mean,
yeah, the LaTeX was the
so
only software which was bug free, right?
Yeah,
because of Knuth.
Everything was made on Unix, so it was Solaris. Not even Solaris. This was before Solaris. That was still Sun OS.
Okay.
Sun OS, HPUX, AIX,
Mm-hmm.
and Linux slowly came in like 1993, 1994.
I work with
My first
HPUX. And HPUX, their beautiful desktop manager. It was the CDE with the 4 buttons for the screens. So it was, and I had Mosaic browser back then. Was really nice. And and Sun came later, which I saw. But I started with this HP, which are beautiful machines actually.
HP did beautiful workstation.
Mm-hmm.
I was lucky enough to work on one of them,
mm-hmm.
and it was just a super
mm-hmm.
great machine. I remember
what?
because we're using so much memory. That's an anecdote from these days. We had to buy. We had a lot of budgets in this lab, and we had to buy more memory for the machine. So we bought a memory device with 512 megabytes of memory on it, and it cost the price of a flat in Paris at that time. We bought it for several 100,000 francs because there was not euros, and that was the price of a flat.
Yeah, I know, because this Windows 95, the first one had 8 megs, and this was 1995, and even 16 megs RAM was already several hundred euros. It was very expensive, and 512 was not possible on Windows back then. I mean, this was technically not possible. I think 32 megs, right, was the most you could put on it, and then you need 16. I think 16
on the motherboard.
Mm-hmm.
The limitation was the motherboard. It was not even the OS itself. Well, there was probably a limitation with the OS, but the real limitation was the motherboard.
Yeah, the OS was 16-bit. Yeah, this was the problem, I think.
Yeah.
Okay, and so what you did is spend time with image recognition and had a beautiful machine. So why you quit the research labs then?
I quit the research lab because I was done with my PhD. I became a doctor in math.
Okay, what is the title of your PhD?
The title of my PhD. So I need to translate it in English.
Yes,
it's
please.
A French title, of course. It was image. Come on. How could I translate that? My God.
We have to ask ChatGPT now.
It was multi-resolution image recognition, basically.
Okay.
The subject of my PhD was to take aerial images, not satellite, but taken from planes, like big images. Even if the nowadays standards, these images were more than 10,000 pixels by 10,000 pixels. So you can imagine to load such an image on a machine that has gloriously several megabytes of memory.
Yeah.
And to process this kind of image in real time, to recognize specific buildings on them. So you have a small image with the picture of the building that you're looking for. You have these big images, and you have like hundreds of buildings on it, if not thousands, and you want to spot this building very quickly. In a matter, and with these parallel machines, it was actually possible to spot these buildings in a matter of a millisecond.
Milliseconds.
Just amazing. Yeah.
Okay. You use neural networks for it or no? Or was just brute force? Or
No, neural networks. Neural networks were not. What there was too many computations to do that. The idea was to use, because these images was stored on the hard drive in compressed forms. So there was this. It was the beginning of the JPEG standard, but there was other algorithms based on a special transform. The JPEG algorithm is based on a transform which is called the cosine transform, and there was other transforms, especially one called the wavelet transforms, which is used in JPEG 2000, but I don't think anybody is using JPEG 2000. So these images were compressed using this algorithm, which is super efficient, much more efficient than JPEG.
I have to laugh. Sorry. You know why? Because in my study, we could pick, how to call it, an additional topic. And there were like 3 topics, and one topic was crazy, like airplanes. And I said, okay, this is cool, but I would like spend time with software engineering. And one topic was multimedia, and I said, this is cool, because multimedia, I can just relax a bit, and maybe we can draw something or whatever. And the multimedia topic was exactly what you said. What, how JPEGs works, all the wavelets, cosine transformation, what you said, lots of math. Absolutely no, the entire year, there was no image. It was just math and transformations, and the others, walk, to the airport and took a look at the airplanes. I always spent, the entire year with maths. So this cosine transformation, I remember we did also this MP3, how it works behind the scenes. It was actually interesting, but completely unexpected. Yeah. So for me, I wanted actually to do something different, right? So don't pick multimedia, and if you study computer science, this is just a good advice, I think.
Well, yes, but it's still interesting because
it was interesting. Yeah,
working. You know what you can do with them. So the idea is that this image was stored in a compressed form, and the idea is to do image recognition on it without having to recreate it, using directly the compressed form directly. So this is what I did, and there was no way neural networks could handle that.
Actually. So you could look at the compressed form and use the recognition on the compressed form.
Yeah.
It's almost like a hash, right? Of the compressed form is almost like encryption, almost.
So it was a specific compression algorithms developed back in the day, which was actually based on the wavelet transform and the storage of edges of the images. And once you have the edges, because the edges were specifically stored in the compressed form, you could use these edges to do the recognition. And because it was a multi-scale, multi-resolution compression, you had from a very coarse resolution to very fine ones, so you could just select portions of the images and go down to the finest resolution to find what you
almost like SVG, almost, right? So
kind of.
Yeah. And you ever thought about porting it to Java or do something for fun right now with Java and Java image right now, or?
Oh, I think it would be fairly easy to port it to Java because the algorithm in itself was not very complex. What was complex and what was costly actually is that these images were very big, and so these were mostly once the algorithm was set up, it was port it and run it in real time, like having a result in a matter of milliseconds, was mostly a problem of memory usage and this kind of thing, and also speeding up of algorithm, because when you in the end you're just working with binary images, which are storing the edges of the buildings you're looking for. This is why I was telling you about recognizing faces and recognizing buildings are 2 different kind of problems, because a building is basically a geometric stuff, right? You have squares, rectangles, triangles, this kind of thing. So if you're looking at this kind of thing, it may work very efficiently. A face is usually not apart from for faces painted by Picasso or this kind of people.
Yeah,
a face is not just a set of squares and rectangles.
Yeah, you're right. The compression wouldn't work, right? Because there's too many edges.
Yeah, exactly. So edge-based algorithm will not work on compressing faces.
Then, if I were a secret agency, I would create a building which is very organic without sharp edges, and then you couldn't recognize me, right?
But if it's the only building like that in New York City,
Ah,
probably it would
yeah,
be
yeah. Good
correct
point.
actually.
It's even easier even easier, no, to recognize. Uh huh.
These images are very blurry, so the edges are not very accurate. So
Okay.
even if it's not exactly a square, it has to
So,
be.
what you did with your knowledge of your PhD after the PhD?
So I started working at the university in Paris,
Hmm.
giving lectures and stuff. I was recruited actually as an assistant professor in
Cool.
1994, 5, 6. I can't remember
Oh, it's as
exactly.
Java happened actually.
Yeah, exactly. And because when you write code and you write more and more complex applications, at some point you're just tired of just writing C and assembly code. You need some kind of higher level language
Hmm.
to
Hmm.
merge all your pieces of components together.
Hmm.
And this was exactly the time when Java was released.
Hmm.
And Java had many promises. First, it's simpler than C++, and that was very good news for me because I didn't really felt like deep diving in C++ and all the complexity of the language. And there were many things that were available right out of the box, like multi-threading, database access through JDBC that was there in the very first version of the language, graphical user interface building using it was even before Swing because Swing was Java 2.
Are you sure that
And
JDBC didn't came with JDK 1.1?
yes, it did. It was JDBC was in the very first version of Java. So
1.0,
you
okay.
if you are 1.0 or 1.1, I can't remember exactly, but it was there very early in
Yeah,
Java
exactly,
2.
very early. But I think JDBC came
Yeah,
1.1 and 1.0 was no JDBC, but because I waited
I
for the
can't remember
JDBC.
exactly.
Yeah, cool.
JDBC, and then they were yes, but I clearly remember that one in 1.1 there was the
Yeah, yeah.
JDBC was there.
1.1 was lots of and interfaces were also came to 1.1. I think they were not in 1.0 back then. And you
And
used and
there are
you
many
were
many.
aware of of Java from day one somehow or
I started the first time I downloaded because we had I was lucky enough to be in a research lab,
Mhm,
and in research lab you had access to this new thing
mhm.
at that time called the internet. So you could download stuff from the US,
Okay.
and this is what I did. So I launched the download of the very early Java distribution when I left my lab in the night, and the following day in the morning I had the download of it
Mhm.
because
5
the
megs
bandwidth
roughly.
was not that much. Yeah, something like that. So I had the distribution and I could start to play with it, and it was working super well. I mean, especially on Sun workstation where
Mhm,
everything was precisely organized so that you could make it work very easily. And it was just C on steroids, super simple to use, super simple to assemble. Everything was working
mhm,
just nice, and you could build simple graphical user interfaces with them to display
mhm,
images and stuff. And it was just working out of the box. I was just amazed by that.
mhm,
And so I started working Java in the very early days. And very soon in the university I was in, there was a need for people doing Java courses. And I was basically the only one able to do that.
mhm.
So this is what I did.
Okay.
This is what I did, and I never stopped because yes, this is
Ah, okay. So you spent the entire time at the university. So if we met at Java 1,
yeah,
you were as a professor.
yeah.
Ah, I didn't knew that. I
I
thought you work. I always knew. We had always a chat, but I had no idea what you are doing. I thought you're working for as a consultant or something. But yeah.
yes. Also, I also did that. I also did consultancy and training,
Okay.
mostly in Java because this is where the business is.
Hmm. And what
But
you
then,
did as consultant, enterprise backend or what's
yeah,
your okay
enterprise backend, um,
glassfish as well and stuff
yeah,
like this.
mostly this kind of thing.
Ah,
Sorry.
okay. So this is how we met, or how I found maybe you, because I also did a lots of glassfish and Java and stuff like
Yeah,
that, and that okay. This
but
is
yes, I
mhm.
remember you came to the Paris Jug several times
Yeah,
to talk
exactly.
about Glassfish
You invited me at Java 1, so we had the first contact. Like sure, and then yeah, I was in Paris. Exactly, it was nice. And you never worked for Sun?
I never worked for Sun. No, I never worked for Sun.
Okay.
I they had offices in Paris,
Hmm.
in Vélizy to be precise, and
Hmm.
I've been there one or twice. mostly to attend Java conferences, communication, Java events.
Mhm.
Yeah, once or twice, something like that. But I never worked for them.
Okay, cool.
I never worked for them.
But and as consultant, you were a freelancer, or what you did?
Yeah,
Ah, okay. So we are
freelance.
very similar, but I'm not a professor, but I'm also freelancing consultant. So similar areas. Okay, and what happened then? Because at one point of time you started to work for Oracle, right?
Yeah, about 3 years ago, I think it was during COVID, right after COVID.
Okay.
Oracle contacted me
Mhm.
and told me that they had an open position to talk about Java on YouTube, social networks, in conferences and stuff. And I was thinking to myself, yeah, what about, I'll give it a try. And
Mhm.
so they hired me. So I just paused my university activity. It's on hold, I would say.
Okay.
Someone else is taking care of my students and stuff,
Mhm.
who are not my students anymore, by the way, because they got their degrees, and I hope they're working in companies and have fun and make good money with it. And yes, this is what I did. I started. When was that? I started 2 years ago and a half, or 3 years ago and a half.
Mhm.
I can't remember exactly.
Mhm.
2 years ago,
Because
something
I
like
was
that.
surprised. I found you on the YouTubes for Oracle, and I always enjoyed
Yeah,
your. I don't know how to call it. It's not a screencast because you always had a coffee in a coffee bar,
yeah.
like the CoffeeCast
It's
or whatever.
yeah, you could call that a coffee cast. That's fine.
Uh-huh.
I like it.
Yeah, and I really enjoyed because it was I just watched all your videos with the coffee because I enjoyed your style. Like, this is really nice what you're
Yeah,
doing, and
thank you.
yeah, and then I also attended your talk at Devox, and it was about several things. But I was surprised about the depth about your talks because you talk exactly about the CMD processors, and also, okay, this is now your background
Yeah,
about vector computing, vectors, Java vectors. This was, I think, the talk,
the vector API.
the vector API, right?
Mm.
And exactly. So what I'm wondering, because back maybe to AI and machine learning, and maybe you are the best person to talk because you have the background knowledge, is that Python and programming languages and Java, right? So my impression is right now, I had a chat with several AI people and Python people, and the scientists in the Python world, they don't care about testing pipelines and nothing. They just I had several. This is my personal observation right now. This was the questions at
Mhm.
conferences, and I got the answers. So maybe I was no echo chamber problem, but they said, for instance, like, why are you using Python? So, and the answer was because I don't care a lot about data structures. I have to make it work first. So we have some experiments. There are the Jupyter notebooks, and we get the results, and then we have the results. And then I ask, okay, but then we have the application, and know how to run your application then, because I mean, I have to talk to your stuff somehow. Is your stuff concurrent or not, or how to integrate now your stuff? And there was no answers basically. And I thought so. This is crazy because the scientists and the machine learning people, they're building something which works on their machines, and this is basically it, right? And then we try somehow to make it work on a larger machine, but I don't. This is very early process, I would say. The entire environment, and I wondered what maybe will happen or should happen is that in one point of time Java will kick in because in Java side we have less scientists, but we know how to run the stuff, right? And Java is also very energy efficient and 35 times more actually energy efficient than Python. And it will be interesting times, to integrate the work of the scientists from the Python world with Java, right?
Probably, but I'm not surprised by what you said, because it's not, when you're a scientist, your goal is not to build applications and to run applications.
Mm-hmm.
That's the work of other people.
Mm-hmm.
But what you need to do is to prove that the algorithm you set up
Yeah.
is actually doing its job, and
Mm-hmm.
it's actually producing good results,
Mm-hmm.
or good enough to be used in applications. And
Yeah.
once you've done that, you write your paper, you present your stuff, you push it to the public, and other people, maybe startups or whatnot, take it and are just making a product out of it.
Yeah, sure,
But
but
it's not your concern anymore.
no, but if you are in a company, so from enterprise, right? So and you have, let's say, a model, even a model, and you download the models from somewhere. Now, at the end of the day, it is a computer program or application, which has to be called, and it does something. So the first question I'm asking myself is how many parallel calculations such model can accept. For instance, there are interesting questions, and I'm really because it's not a problem to call ChatGPT API. I mean, this is boring. But what will also happen, I guess, you will get models on premise, because there are some algorithms which are interesting for companies, and this will be really interesting part, how to call the stuff. And then maybe the Java Vector API, Project Panama, and stuff like that will be or Babylon will be very interesting. How to integrate with boring Java code, the work of AI, right? So, or the result of a scientist, let's say.
I'm not sure I'm the best person to answer this kind of question, because the real question is, where is your model? What you call the model is all this neural network stuff that is running somewhere on the cloud, that is handling these massive amounts of data. Why are you going to run that on what kind of device? And do you have the manpower to rewrite everything, to rewrite the model with your own language and stuff? What are you going to do if you're a company, big or small, and you want to integrate this kind of stuff in your system? What are you going to do? You are going to target the right people, try to hire them, integrate them in your teams, and okay, now you do the same for us. But these people, they are going to use the language they know. Okay, you are going to do that for us in Java. Oh, I'm a Python programmer. I can't do that. Well, what are you going to do? You are going to write some Python code in your application, and that's it. And if it's not Python, if it's something else, you are going to it's just a matter of being pragmatic, I think. So nowadays, Python has conquered this world. What are the reasons for that? We can try to dig into that and understand that. Is it really interesting to understand that? I'm not so sure, to be honest. But the fact is, people are using that. Now, if you have a system, a software system, several millions lines of code, and you want to interface it with this kind of code, which is written in Python, you need to have a bridge between both worlds.
Exactly.
And indeed, Panama is giving you, or will give you in the next few months or years, a right technical answer to do that. If you want to speed up your computations, maybe because in this kind of model, your computations are done on a cloud or cloud-based data structure and computing, and you're just pulling the results in your Java applications. So Java is good at that. You just keep that. But if you want to make it run faster, your deep learning stuff faster, then you need to rewrite that with faster languages, more efficient languages, and this kind of thing.
So my understanding is
all this stuff. Yeah.
My understanding is anyway that the Python is just a glue which calls the C parts. This is what I understand, and this is what because the low level machine learning libraries are written in C anyway, and the Python is just a nice to have DSL which calls the parts. So if Panama is working well, maybe there will be some Java project which call the C parts directly, and Java can become the DSL, and then it will be just easier to integrate in the ecosystem. Because calling ChatGPT,
it means that you still need to rewrite all this Python glue stuff in Java. Do you have the manpower to do that?
No idea.
Just able to do that. Know Java well enough to write correct Java code to do that. If it's not the case, it's a lost cause.
Look, sure. I'm just thinking. What becomes. Is it a problem big enough, that you say, okay, there's not a problem at all because we can run, I don't know, Python or GraalVM, let's say, right? And then it's integrated. Yeah. So this is the integration, or is it so painful that we have to know because I think that some kind of, AI powered applications can be dominant, in at least in the next 2 years, and the entire, pipeline CI/CD is also affected somehow because we need to know versioning and testing, which is also everything is a little bit more interesting or challenging, right? Yeah. But Java is good stuff. What happened? So I would say even the Project Panama, which is better Gen I, right? Let's call it. It's great stuff which happens, and also the how it's called, I think, code reflection, right? So like reflection on the Java source level. So I would say Java was, I would even claim, was never so innovative like right now. So lots of innovation happens right now. Or is it also your impression, right?
Yes, absolutely. There is a big pipeline of new stuff that is coming up, and that is super exciting.
And now it comes to know,
API and the Panama is just one part of it. So many things.
And now it's a pace by pace. More stuff is coming out right now, right?
The big difference is that back in the days of Java 8, you had all the features in one go. It was a big bang. The release of Java 8 was a big bang. Lambdas, streams, collectors, everything in one go. You had to digest everything in one go. It took 3 to 4 years to do that. So big. And but now with this new release cadence, which is not new anymore because it has been there for several years, you have things one piece at a time. So pattern matching, for instance, is really one piece at a time, and everything around that is one piece at a time. Maybe Loom was more like a big bang because you had virtual threads in one go, and there was probably no other way to do it. By the way.
But my impression in Java is that the features happens once per time, but they have a large vision in mind. And now we are almost break even. So now it comes more and more, which is synchronized and makes sense, right? We can use the record patterns in switch expressions, for instance, and these both features are synchronized and great things happen. So deconstruction, stuff like that. It was not, but it is only possible because we get multiple things at once. So this is the cool thing. We got small features, but if you look at all the features, you can combine the features and something larger happens, right? And now it's the time where we see more and more things coming. What I also really impressed or waiting badly for string templates, actually, hopefully in Java 22, right? So because I always, what I wanted to do is I wanted to reboot JSPs, right? Because it's like I would like to have just a Java server page without the scriptlets, just as a templating things. Quarkus as Qt is okay, but JSPs were actually good enough. But I would need servlets, and I thought, okay, Jaspar maybe pick from Tomcat. But string templates is actually the right answer. And string templates were really exciting because you could even at build time, or how to call it, at compile time, you could check, JDBC, right? Metadata or whatever. So it is actually big times what happening then. And fun times. But if you think, we could have another, meeting and just talk about Java 21. Because now we know you, I know what you are doing, right? So you are the absolute expert in CCMDs, craze, and great machines, and Java right now. And we can have your point of view, the most exciting Java 21 features, and we have one episode just about Java 21, for instance, and Java 22. Then, like as a preview, it would be a really nice session with you.
Java 21 is probably the most exciting stuff because people are going to actually work with it because it's an LTS version, etc.
And LTS, exactly.
To say that. Yeah.
I go now to companies and
will not be an LTS, so I'm not sure that people will actually adopt 21.
What I'm doing right now,
definitely adopt 21.
I go to companies and say, look, we have to migrate to Java 21. Java 17 is no more secure. This is old stuff, legacy. We have to do it. And say, okay, then you have to Java 21. This is the the secret weapon. Okay, where people can find you on the internet? What's your YouTube and your Twitter and whatever?
Twitter, José Pomar is my Twitter handle. So if you just Google for my name, you'll find it. YouTube, I publish quite a lot of stuff on YouTube on the Java channel. So youtube.com/Java. And you'll get this Jeb Cafe series you talked about.
Okay.
And also, I also have another series of shorts, which is very nice, very funny to make shorts. I really love that. And I have a little more than 100 episodes, must be 103 or 4 something. And there are 2 episodes a week, and and that's it. And I'm also giving talks at conferences, so sometimes conferences publish this on YouTube also. Yeah,
and your talks are great, so I really like them.
Thank you.
Everything you did is actually really entertaining and good, also deep, so which I really appreciate. Thank you a lot, and see you next time. I would really re-invite you back. Absolutely. And had really nice conversation about Java 21. So looking forward to it.
Absolutely, looking forward to it too. See you. Bye.